Hello and welcome to Exam Masters. Today we have chemistry past questions and answers, and we are going to look at JAMB 2019 from question number 1 to question number 10. Let's get started. Question number 1. Which of the following constitutes the least environmental pollution? What the question is saying is, which of the following option is the least dangerous environmental pollutants? Option A, CO. Option B, SO2. Option C, CO2. Option D, chlorofluorocarbon. The correct answer is C, CO2, because CO, which is option A, depletes the ozone layer. Option B, SO2, causes acid rain. Option D also depletes the ozone layer. Therefore, option C, which is CO2, is the one that is least environmental pollutants, or the one that causes least environmental pollution among these options. When CO2 is produced in the environment, maybe by animals, the plants around easily take it up and use it in their own respiration. So there is always a balance between the production and utilization of CO2 in the environment. But excess CO, excess SO2, and excess chlorofluorocarbon in the environment will always lead to a very serious environmental pollution. Question number 2. What is the pH of 0.001 molar solution of HCl? To solve this question, we know that pH is equal to negative logarithm of hydrogen ion concentration. Now, if we want to solve this, we have to determine how many hydrogen ion can be produced from HCl. HCl, if it is dissociated or if it is ionized, it will give hydrogen ion plus chloride ion. So we have 1 mole. If we use 1 mole here, we are going to use 1 mole here. So since we are using 0.001 of this HCl, we are also going to produce 0.001 of hydrogen ion. Now, we can now put this value for this hydrogen ion concentration here and then solve. So we are now going to have that our pH, the pH now is equal to minus log of 0.001, and that will give us minus log 10 raised to power minus 3. 0.001 is equal to 10 raised to power minus 3 if we convert it to standard form, and that will give us minus 0.001 minus 1 times minus 3 log. Natural logarithm is log 10. If you have log 10, it will give us 1. So we are going to have minus 1 times minus 3, which will give us 3. So the answer is 3. You can also use your calculator direct and solve this by looking for minus log 0.001. It will give you 3. So the correct answer is 3, which is C. Question number 3. Which of the following has the highest hydroxyl ion concentration? A. HCl. B. Ammonium hydroxide NH4OH. C. HNO3. D. NaOH, sodium hydroxide. Now, among these options, this and this, they are bases. Bases, they give us hydroxyl ion, while acids give us hydrogen ion. So we are going to concentrate on these two. This and this, they are acids, while this and this, they are bases. Now, our work now is to find out between this one and this one, which one will give us higher hydroxyl ion concentration. Ammonium hydroxide is a weak base. A weak base is one which does not ionize completely. A weak base is one or is a base that does not ionize completely. And if the base does not ionize completely, it means that some of its hydroxyl ion will not be released when it ionizes. NaOH, sodium hydroxide, is a very strong base. It ionizes completely, which means that when it ionizes, all its hydroxyl ion will be released. So if we ionize this one, some of the OH here will not be released. But if we ionize this one, all the OH this place will be released, which means that this one will give higher hydroxyl ion concentration. So the correct answer is D, NaOH. Question number 4. The best technique for separating the components of a dye is A. Chromatography, B. Distillation, C. Evaporation, D. Filtration. The correct answer is A. Chromatography. The reason is because chromatography is the method of separation or a separation technique that is best used if we want to separate colors or something that contains colors. We use chromatography. The technique is based on the migration of the components of the colors. If we want to use chromatography, the technique is based on this principle. If you put something like a dye in a filter paper, or if you drop it on a filter paper, you will notice that after some time, the components of the dye will start separating. Every color, most colors are made up of other colors that combine to form that particular color. During chromatography, those colors that make up that particular one will start separating. So if the color is something like magenta, magenta is made up of blue and red. So if you pass it through chromatography, that's blue and red, which made up the magenta color, will start separating. So you have different bands or different areas. One will be showing blue and one will be showing red. Now, how chromatography helps this thing to separate is because different colors move at different speeds. So if you take your time, if you keep the paper where you dropped the color, after some time, maybe the blue color will stay here, while the red color would have gotten to this side. So you see different colors on that filter paper. So that is a simple case of chromatography, although we have more complicated or more complex equipment for doing chromatography. So chromatography is the best answer for this, option A. Question number 5. What is the volume of a gas at 20 degrees Celsius if its original volume at 60 degrees Celsius is 300 cm cube at constant pressure? We have here volume, we have T1, which is equal to 20, and we have V1, we don't know the initial volume, and we have V2 is equal to 300, and we have T2 equal to 60 degrees Celsius. This is in Celsius or in degrees centigrade. Centigrade or Celsius. When we have temperature and volume varying, or the temperature and volume of a gas varying, that is a case of Charles' law. At constant pressure, the pressure is constant here, so this is a case of Charles' law. So we are going to use Charles' law to solve this. Now we must convert our temperature to Kelvin. This 20 degrees centigrade that is given to us, we have to convert it to Kelvin if we are solving anything in gas law. So we have 20 to convert to Kelvin. We add 273 to the temperature that is given to us in Celsius or centigrade. Now we have 20 plus 273. We just add 273 to it. And when we do that, we are going to have plus 273, we have 293, and for 60 we are going to have 60 plus 273, and that will give us 333 Kelvin. This one in Kelvin. Now with this we can now start solving. To solve using Charles' law, Charles' law states that the volume varies directly as temperature at constant pressure. We have volume varies directly as T at constant temperature. We have V is equal to KT. If we clear the sign of proportionality, if we want to remove this, we put K. We introduce K and then put equality sign. Then if we want to make K the subject of the formula, if we want to make K to stand alone, then we take T to this side. It is multiplication here. We take it to this side, it becomes division. So K is equal to V over T. So if we have different volume and different temperature, then we can now say that V1 over T1 is equal to V2 over T2. This is Charles' law. This is Charles' law. So we now put everything here. We look for our V1 and put it there. Look for our T1, put it there. Look for our T2, put it there, and look for the one that we don't have. Now substituting, we are now going to have this. Our V1 is equal to we are looking for V1, and T1 is 293, and V2 is 300, and T2 is equal to 333. Now that gives us, if we do cross multiplication, take this one to this and take this one to this, then we have that 333 times by V1 is equal to 293 times by 300. That will give us that 300 V1, or let's just make V1 the subject straight away. So V1 is equal to 293 times by 300 over 333. Now that will give us that, if we do the calculation, that will give us that V1 is equal to 264 cm cube. 264 cm cube. I calculate it very well. So the option actually is not in this question. What we got here is not in the options. So probably they decided not to give the correct answer. If you see something like this, you can leave that option blank. The correct answer is this. Then question number 6. CaCO3 plus 2HCl is equal to CaCl2 plus H2O plus CO2. From the equation above, what mass of CaCO3 will be required to produce 11.1 gram of CaCl2? We are given that Ca is equal to 40, C is equal to 12, O is equal to 16, and Cl is equal to 35.5. How can we solve this? We say that from this we see that calcium carbonate, which is CaCO3, 1 mole of calcium carbonate, 1 mole of calcium carbonate, which is CaCO3, produces how many moles of CaCl3? It produces just one. One here produces 1 mole here. So we have 1. If 1 gives us 1, 1 gives us 1. 1 mole of CaCO3 is equal to its molar mass. The molar mass of this is what? It is equal to the molar mass of CaCO3 is equal to mass of this is 40 plus mass of this is carbon is 12 plus oxygen is 16, and we have 3 oxygen. That will give us 100. So the molar mass of this is 100. Then the molar mass of this one, CaCl2, is equal to CaCl2. This is equal to 40. This is equal to 35.5 times 2, and that's, if we add 2 of them, everything will give us 111. We have 111. So in essence, what it means is that since we have that 1 mole of CaCO3 gives us 1 mole of CaCl2, it means that 100 gram of this gives us 111 gram of CaCl2. Now in the question, we are asked what mass of CaCO3 will be required to produce 11.1 gram of CaCl3. So we can call that unknown X what mass of CaCO3 will be required to produce 11.1. So that is, if 100 gram gives us 111 gram, how many will give us 11.1? Let's do cross multiplication again. We have this to this, we have this to this. Now we can say that X times E times 111 is equal to 100 times 11.1. Then X, which is what we are looking for, is equal to 100 times 11.1. Sorry, yes, 100 times 11.1 over 111, and that will give us that X is equal to this will give us 10 gram. This will give us 10 gram. So the correct answer is 10 gram. The correct answer is 10 gram, which is A. Question number 7. What volume of oxygen will be present in 150 cm³ of air at 27 degrees Celsius? This question requires us to bring to our mind the composition of air. If you can't remember the composition of air, you may not be able to answer this question. Air is made up of different components including nitrogen, oxygen, CO2, and rare gases. What is their compositions? Nitrogen N. A is made up of 78% of nitrogen. Then oxygen is 21%. CO2 is 0.03%, and rare gases rare gases is equal to 0.97%. Now, the question asks of what volume of oxygen will be present in 150 cm cube. Now, what this composition means is that if we have 100 cm cube of oxygen, it is going to contain 78 cm cube of nitrogen, 21 cm cube of oxygen, 0.03 cm cube of CO2, and 0.97 cm cube of rare gases. So we have that if 100 cm cube of oxygen of air will give us 21 cm cube of oxygen, 150 cm cube of air will give us how many? Together we still do cross multiplication. Take this to this, take this to this, then we have that 100 times x is equal to 21 times 150, and we have that x is equal to 21 times 150 over 100, and that will give us that x is equal to therefore equal to that will give us x is equal to 31.5 cm cube. If you do the calculation, it will give us this. Do we have this in the options? Yes, that is option B. So option B is the correct answer. Question number 8. Which of the following is suitable for removing both temporary and permanent hardness? Hardness in water can be temporary or permanent, and we have different methods we can use to separate or to remove each of the different types of hardness in water. But there is a particular method that I can use to remove any kind of hardness in water, and that is any method that will give you pure substance or pure water. Anything you can employ to get pure water, it will remove both the temporary hardness and permanent hardness. If you go to pure water production industry, the major equipment they have there is what they call distillation machine. Distillation machine simply removes all the permanent, everything that causes permanent hardness and temporary hardness in water, and any kind of impurity, giving you water that is pure. So distillation is a method that will give you pure water by removing any impurity that might cause temporary or permanent hardness to the water. The correct answer is C. Question number 9. C2H4 plus 3O2 gives us 2CO2 plus 2H2O. From the reaction above, what mole of CO2 will be produced from 56 grams of ethane? This is ethane, C2H4. How much or what mole of CO2 will be produced from 56 grams of ethane? We are given that C is equal to 12 and H is equal to 1. Now, our work here is to identify how many moles how many moles of, this is 1 mole of ethane here. It gives us 2 moles of CO2. Now, this 1 mole of ethane, what is the molar mass of it? When we get it, we say that that molar mass gives us 2 moles of this. Therefore, this one will give us what? Look at what I'm going to do now. 1 mole of ethane gives us 2 moles of CO2. 1 mole of ethane, which is C2H4, is the same thing as saying C is equal to 12. So we have 12 times 2 plus H is equal to 1. So we have 1 times 4. And this will give us ethane. This will give us 12, 24 plus 4, that is 28. So we have, this will give us 28. So we now have that this 1 mole is equivalent to 28 gram. So we have that 28 gram gives us 2 moles. Therefore, 56 gram will give us how many moles? 56 gram will give us how many moles? Do cross multiplication. Take this one to this and take this one to this, and we are going to have that 28 times x is equal to 56 times 2, and x is equal to 56 times 2 over 28. This will give us that x is equal to 4. X is equal to 4. So the correct answer is A. We are going to produce 4 moles of CO2 by using 56 gram of ethane. Question number 10. Which of the following contains particles with the largest size? A. Aqueous solution. B. Suspension. C. Emulsion. D. Gel. The size of particles increases this way. We have through solution, which may also be aqueous solution. Through solution has smaller particles than force solution. Force solution may also be called colloidal solution. Colloidal solution. Then, and colloidal solution or force solution, we have smaller particles than suspension. Suspension has the highest or the largest size of particles. In suspension, if you leave a suspension to stand for a while, the particles, because they are heavy, because they are large, they will settle down to the bottom of the solution. So if you see any solution that if you leave it to stand for a while, the particle will settle down to the bottom, that solution is a suspension. It is because the particles there are very large and they are heavy, so they are able to settle down to the bottom of the solution. So in these options, suspension is the one with the largest size. The correct answer is B. So we have answered question number 1 to 10 in chemistry, JAMB Chemistry 2019. And this brings us to the end of this video. Thank you.